Good morning, student. Yes, student, today we will study in this online class of physics for 10th. Chapter is here magnetic effect of electric current, in which the topic is electric motor. Okay. Dear student, I told you in the previous video about the magnetic field pattern through the solenoid. I told you in the previous video about the magnetic field pattern through the solenoid. And what are the importance of solenoid? I told you in the previous video. Now you will study electric motor. Dear student, in your syllabus you will study electric motor, but you will not study electric generator because which is not in your syllabus. Here the electric motor. Electric motor is that device which convert electrical energy into mechanical energy. Dear student, electric motor is that device which convert electrical energy into mechanical energy. Electrical energy into mechanical energy. Like for the operating, just like in refrigerator also, and in mixer, and in cooler, and in tele pump also. So where the electric motor is used. Electric motor is used to operate some machines like in cooler, refrigerator, and mixer, and tele pump also. Dear student, electric motor is that device which convert electrical energy into mechanical energy. Electric motor is based on the principle of magnetic effect of current. I told you magnetic effect of current in the previous video. Here in this case, when the rectangular coil is placed between the strong field magnet, and pass the current through it, then it begin to rotate. Because here the force is act. Because when the rectangular coil is placed between the strong field magnet, now pass through the current, then the force is act on this coil and which begin to rotate, or which make the rotation. And when it begin to rotate, like in anti-clock and in clockwise, it is depend on the direction of current. Because when the direction of current in upward, and now it begin to rotate in anti-clockwise, I told you in the previous video. But when the current in downward, it begin to rotate in clockwise direction. Okay? Because when the rectangular coil or the armature, we can say also armature. Rectangular coil is the armature, which are placed between the strong field magnet and both end is connected with the split ring. Here the split ring is called commutator ring. Which other name is commutator ring, and attach carbon brushes also. There are two carbon brushes, and now here the carbon brushes which are connect with the wire and which are connect with the battery and key also. When the key is switched, which are on, or then the circuit is closed. When the circuit is closed, now the current pass through this coil. Okay, here in this case, where split ring. Where the function of split ring or the commutator ring, and here to change the direction of current at every half rotation. Because when the coil which are placed initially in horizontal, and when it begin to rotate and it become vertical, now when cut off the current, but it does not stop. Rotation it does not stop, but cut off the current due to the inertia of motion, because it already gained momentum, and so it begin to rotate. When again it comes back in their horizontal position, and here change the direction of current, and when the coil rotate and it horizontal to become vertical. You will see in the diagram also. I will make here. When it goes in vertical position, now cut off the current. But when the current is cut off, but it already gained the momentum, so it does not stop. So the rotation does not stop. And when again, it means this side, this is the side, and this is also side. Now this side it come back in this side. It means right to left and left to right. And it means right side goes in left side and left side goes in right side. So here the commutator ring and the carbon brushes make the contact. Carbon brushes make the contact at every half rotation. Now again the current pass through it. Now this process is continued, and to change the direction of current and make the contact and make the contact of the ring here by the carbon brushes. So the function of carbon brushes to make the contact at every hop rotation, and function of commutator ring is what? Change the direction of current at every hop rotation. Okay, you will see in the diagram. First of all, what is the electric motor? It is a device. It is a electric motor is a device and which convert electrical energy into mechanical energy. A motor is a device, or electric motor is a device, because there are two types of motor. One is AC and other is DC. So we can say that electric motor here we will study. Then after DC motor, electric motor which work on the supply of alternating current. AC and DC. AC is for alternating current and DC is direct current. The motor which work by the supply of AC is called AC motor, and the motor which work by supplying of DC is called the DC motor. DC motor is also used in toy car, in some other appliances, electrical appliances, but which work on the supply of direct current, not alternating current. Okay, that motor is called DC motor, but which work by the supply of alternating current, which is called AC motor. Here we will study AC motor, alternating current motor or electric motor. A motor which convert. A motor is a device. A motor is a device which convert. A motor is a device which converts electrical energy. Which converts electrical energy into mechanical energy. I told you about the mechanical energy. Mechanical energy is the sum of kinetic and potential energy. In the previous video I told you what is the mechanical energy? Sum of the potential and kinetic energy. So what is the electric motor? A motor is a device which converts electrical energy into mechanical energy. And what is generator? It is that device which converts mechanical energy into electrical energy. But a motor is what? It is converts electrical energy into mechanical energy. Just opposite. Okay? Electric motor which work on the electric motor which works on the principle of magnetic effect of current. Magnetic effect of current. Dear student, motor which work on the principle of magnetic effect of current, but generator which work on the electromagnetic induction. Okay? So here motor which work on the principle of magnetic effect of current. How? When the rectangular coil placed between the strong field magnet and passed current through it, then the force act on this coil and which make the rotation. Here the shaft which are used in this motor and which begin to rotate, okay, according to the direction of current. So here when the rectangular coil is placed between the strong field magnet or horseshoe magnet or electromagnet, strong field magnet, and current is passed through it, okay, and then the force is act on this coil and now it begin to rotate or which make the rotation. Here the direction of magnetic field we can find, or the direction of here the force or the direction of motion of conductor, direction of motion of coil we can find with the help of Fleming left hand rule. This is the Fleming left hand rule. When we stretch our three fingers in such way, they are mutually perpendicular to each other. Here you can say this is also 90 degree, this is the 90 degree. It means when we stretch our three fingers in such way, they are mutually perpendicular to each other. Then our first forefinger, this is the first forefinger, which is point in the direction of magnetic field, and the central finger is pointed in the direction of current. Then our thumb point gives us the direction of force or the direction of motion of coil. So we can use Fleming left hand rule in the electric motor, and we can use Fleming right hand rule in the electric generator. Because here this rule is used to find the direction of induced current, but this rule is used to find the direction of force or the direction of motion of coil, direction of motion of conductor, direction of motion of coil, or the direction of force also. Where first forefinger is pointed in the direction of magnetic field and central finger is pointed in the direction of current, but then our thumb point gives us the direction of motion of conductor or the direction of force, like this. This is here. This is the direction of magnetic field, direction of current, and this is the direction of force. Here you can see. This is the Fleming left hand rule. Fleming left hand rule is used to find the direction of motion of coil and the direction of motion of force. Direction of force, not direction of motion of force. Direction of force and direction of motion of coil. We can use this rule to determine the direction of force and the direction of motion of coil. This is called the Fleming left hand rule. This is very important. Fleming left hand rule and Fleming right hand rule. So here you will see that when the rectangular coil is placed between the strong field magnet and current pass through it, and then the force is act on this coil and which make the rotation. And if the direction of current in upward, now it begin to rotate in anti-clock. If the direction of current in downward, now it begin to rotate in clockwise direction. Here you will see the diagram of electric motor. Now you will see here the diagram. First of all, we make it here a rectangular coil. Rectangular coil which is called armature. This is a rectangular coil. Why it is called rectangular? Because the shape is in rectangle form. A, B, C, D. This is the side of rectangular coil. And both end of this coil connect with the split ring. Split ring is called semicircular ring or commutator ring. Okay? This is the split ring. Which is called semicircular ring. C1 and C2. C1, C2. Semicircular ring or commutator ring or split ring. And here attach the two carbon brushes. Carbon brushes B1, second carbon brushes B2. Okay? And here this carbon brushes which are connect with the battery key. Okay, this is the plus minus key. Here this is the C1 C2. C1 C2 is what? Commutator ring. B1 B2 is what? Carbon brushes. Carbon brushes not rotate. Rotate is here what only armature, and here the split ring. This is the shaft. And when this rectangular coil is placed between the strong field magnet or the horseshoe magnet, carbon brushes. Here given V2, this is the N and S, X and Y. Strong field magnet. Okay? When this coil on the armature placed between the strong field magnet like this, and here you will show that Fleming left hand rule. This is the direction of magnetic field, direction of current, direction of current. Now here, this is the direction of force. Okay? This is the electric motor. Dear student, when this coil is placed between the strong field magnet, this is the strong field magnet, this is the coil, this is the magnet, strong field magnet, and when the current passed through it, suppose that current is passed through the side AB in upward direction. Now the magnetic field is produced when the current flow passed through this coil, then the magnetic field generates around the coil. And if it is passed in upward direction, now it will be anti-clockwise. I told you. And here the direction of force, magnetic field is here, and this is the direction of current. Now the force is act on this coil like this. Force is act on this coil. Now it move in downward direction, and this side moving upward direction. It means AB moving down and CD moving upward. Now it begin to rotate. Coil begin to rotate when the force is act on this side. But when it goes in vertical position, right here, when it goes in vertical position, now cut off the current, because here this is the current. Now cut off the current. But it does not stop, because it already gained the momentum. So it moves once again. Now here this side, which is in right place, which is goes in left place, and this side which is in, first of all, initially left side, now it goes in right side. So at every half rotation, change the direction of current by the action of a split ring. This is a split ring. A split ring. And this is the carbon brushes. V1 and V2 is the carbon brushes, and which make the contact at every half rotation. Now this process continue again and again. Now here the electrical energy convert into mechanical energy, because mechanical energy is the sum of kinetic and potential energy. Here we can see that mechanical energy, which is equal to sum of kinetic energy and potential energy. By this device, we can convert electrical energy into mechanical energy. Okay? Electrical energy into mechanical energy. Dear student, here we can convert electrical energy into mechanical energy by the electric motor. It is a direct device and which convert electrical energy into mechanical energy, and which work on the principle of magnetic effect of current. Because when here the coil here begin to rotate by the action of force, because when the current pass through this coil, now it begin to rotate and now cut the magnetic field lines. Now generate the EMF, electromotive force. By the action of force, it make the rotate, because here the shaft which is used in this coil and which begin to rotate, and now when it begin to rotate, now the mechanical energy which is generated, because electrical energy converted into mechanical energy by this device. It is called electric motor. Dear student, you will write here application of electric motor, uses of electric motor, and you will make this diagram also.